All right, the 12-2 homework. Number one, why not? Which situation describes conditional probability? Uh, so that means that our events influence each other. One event happens given the other event has already occurred. Let's see, number three, Gabriella has 20 quarters, 15 dimes, 7 nickels, and 8 pennies in a jar. After taking 6 quarters out of the jar, what will be the probability of Gabriella randomly selecting a quarter from the coins left in the jar? So we don't even need to consider here. We just need to realize that there's fewer quarters. Well, now there's 14 quarters. And let's see what was in here. Originally, this thing had 20, 15, that's 35, 42, 50. There were 50 coins. We removed 6. That means there's 44 left. All right? So 14 and 44. Why the author of this question didn't reduce the fraction, I don't know. Not doing it. Let's see here. A fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers the events that a customer uses the drive-through and F, that a customer orders French fries are dependent. The following data are given in a report. So you're told that the probability of ordering French fries is 8/10, and the probability of the drive-through and ordering French fries is 456 thousandths. Given this information, the probability of using the drive-through, given we have purchased French fries, is what? I feel like this one's in your notes, but anyways, probability of the drive-through given French fries is the probability of the drive-through and French fries sitting over the probability of French fries. Notice how the things in the bottom stay in the bottom. But the drive-through and French fries is 0.456. Probability of French fries is 8/10. And whatever that reduces to, which is probably choice 1 or choice 2. Oh yeah, I've got the old school stuff up here. Anyways, we got what, 0.456 divided by 8/10. Oh, that's gonna grow. I don't know what I'm thinking. It's not gonna be choice 1 or 2. It's 0.57, choice 3. All right, number 7, Mr. Zachary posts review assignments on the Betamath website for his students. On his last test, 49% of his students used Betamath and passed. Overall, 68% of his students used Betamath. Approximately what percentage of Mr. Zachary's students passed given they used Betamath? So we're wanting the probability of passing given Betamath. That would be the probability of passing and Betamath, sitting over the probability of Betamath. Now, the probability of passing and Betamath is right here. On his last test, 49% of his students used Betamath and passed. Overall, 68% of his students used Betamath. That's the probability of Betamath. And we just got to reduce these numbers on down. So it's 49 out of 68. 72%. So passing given they use Betamath, pretty good. It really is. Because you got to think about 51% of his students. Well, anyways, the pass rate difference here isn't much. I can't think this morning. Let's see. Sean's team has a baseball game tomorrow. He pitches 50% of the games. There's a 40% chance of rain during the game tomorrow. If the probability that it rains given that Sean pitches is 40%, it can be concluded these two events are what? Well, they shouldn't be dependent. They shouldn't be. They should be completely independent game probabilities here, but they're independent. Like, they have to be independent. Sean is not going to influence the rain. I don't care who you are. 11, the guidance department has reported that of the senior class, 2.3% are members of the Key Club K, 8.6% are enrolled in AP Physics, P, and 1.9% are in both. Determine the probability of P given K to the nearest tenth of a percent. So probability of P given K, so AP Physics, given you're in the Key Club, K, would be the probability of P and K sitting over the probability of event K. So probability of being event K is 2.3%. 8.6% are in AP Physics, and 1.9% are in both. That's what I want, the both. So they gave us some extra stuff. It's just 1.9, sitting pretty over 2.3. And they wanted the nearest tenth, so 0.8. I think they said nearest tenth of a percent. Oh, actually, hold on. It's 0.83. Actually, let me go at 0.826. I can't round this morning. So that's 82.6%. There we go. They want it as a percent. Not too bad. All right, probability that a resident of a housing community opposes spending money for community improvement on plumbing issues is 0.8. Probability that a resident favors spending money on improving walkways given the resident opposes spending money on plumbing issues is 0.85. Determine the probability that a randomly selected resident opposes spending money on plumbing issues and favors spending money on walkways. Whew. So what do they give us here? They give us this sentence: the probability that a resident favors spending money given they oppose spending money on plumbing. So walkways opposing plumbing. Probability of walkways opposing plumbing is 0.85. And I'm going to start with this. The probability of walkways opposing plumbing should be the probability of walkways and plumbing, sitting pretty over the probability of opposing plumbing. All right, so let's substitute in there. All right. Probability for opposing plumbing issues is 0.8. Why would not? Now determine the probability that a randomly selected resident opposes spending money on plumbing and favors. So this is what we want up here. The formulas actually make some of this stuff make click because you just got to figure out where things go and then you take care of it. Now all we got to do is multiply both sides by 0.8, and this thing is done. 0.8 times 0.85, 0.68. So probability of W and P supporting improving the walkways and opposing spending money on plumbing is 0.68 or 68%. So I guess I'll do number 2 since they seem to be doing every other problem here. Table below shows the food preferences of sports fans whose favorite sport is football or baseball. The probability that a fan prefers pizza given they prefer football is what? So I only care about the football people. And if I can add, I will notice there are 40 people. It's going to be out of 40. Now, the number of people who like pizza is 20. 20 and 40 is a half. Not doing it. So there you go. That is exactly half your homework. You are very, very welcome.